Welcome to my channel once again. This is Teacher Atari. In our previous lesson, we discussed what is known as basic terms in organic chemistry. Today, I'm going to go more deeper. So today, I'm going to talk about classification of organic compounds. See, these organic compounds are classified for easy identification, and they use similar characteristics to arrange these compounds. So according to this now, in these terms, I'm going to use two organic compounds are classified into two, known as aliphatic organic compounds. So they also classify as aromatic organic compounds. So in this aspect, we are going to talk more about the basic terms that should not confuse us as a student. One of them, I'm going to talk about what is known as acyclic organic compounds. So we're going to talk about cyclic organic compounds. So we're going to talk about cyclic, acyclic. We have saturated hydrocarbons, saturated organic compounds. So we're going to talk about unsaturated organic compounds. So in this now, we said, let me go for this aliphatic organic compound. These aliphatic organic compounds are compounds that are composed of chains of carbon atoms. So these compounds can be straight, or branch. So what will be by straight organic compound? The carbons are arranged in a straight format on a plane. By this branch, they have a different arrangement using the structural formula. So aliphatic organic compounds, also known as cyclic organic compounds, are known as acyclic. They are not cyclic. That is what I mean. They use acyclic. They are not cyclic hydrocarbons. So when we talk about aromatic organic compounds, these are compounds that are in form of ring. They are known as cyclic organic compounds. So these compounds, a very good example is a benzene. Benzene is arranged in a ring. So these acyclic organic compounds, they can be straight organic compounds or branch. They are branch. Only by branch, the carbon contain a substituent like alkyl group. Like I've explained what is known as alkyl group. So what we mean by saturated organic compounds? Saturated organic compounds are compounds that carbon, the bond that are bonded between carbon to carbon atoms are held together by a single bond. For instance, now let's use this as a very good example. If you use this now, if you check this compound, the bond that bond this carbon and this carbon, they are all made up of single bond. So this kind of organic compound is known as saturated. So they have full hydrogen that is bonded tetrahedrally. So when we talk about unsaturated, we talk about unsaturated when you see a double bond in the compound. When you see this double bond or triple bond, we say this kind of compound is known as unsaturated organic compounds. So don't be confused with these terms when you see them in your textbooks or your exam. So acyclic can be straight or branch chain. A very good example is aliphatic organic compounds. So we talk about aromatic organic compounds. These are cyclic. E.g., we have the benzene. So when we talk about saturated, when the carbon to carbon bond is a single bond all through this compound, we said it's what a compound is saturated with hydrogen atoms. So unsaturated, we have double or triple bonds. Yeah, when the compound contains any of these double or triple bond, we said it is known as unsaturated organic compounds. So what I mean by aromatic organic compounds, I've said they are what? These compounds are arranged in a ring, form of cyclic and cyclic. So we're going to move directly to what is known as a very classification under aliphatic organic compounds. So aliphatic organic compounds are divided into three families. We have the alkane, we have the alkane, we have the alkane, we have the alkane, we have the alkyne. Alkyne. This is the major. So for me to know this alkane, their carbon to carbon is made up of a single bond. Yeah, carbon to carbon is made up of double bond. Alkyne, carbon to carbon is made up of what? Of triple bond. So as I was explaining this functional group, we are explaining terms in organic chemistry. We said this is known as functional group. So with the help of this functional group, I'll be able to tell the family which this compound falls. So for instance, if I should have carbon to carbon like this, carbon to carbon, we're going to have triple bond here to see. So we have a functional group. We have here we have double bond, functional group. So this is single bond. This is double bond. I mean, this is single bond. The one with triple bond, known as what? This is the functional group of this alkane. So by so doing, I'm going to talk more of each of these family using a very specific family example. I'm going to use each of the first member. Each of these first member are going to use, and let's talk about the alkane. So the alkane, all the organic compounds, we are going to discuss from 1 to 10. We are going to talk about 10. I'm going to talk about one of the simplest member of this alkane is the methane. So the second member is ethane. So the third member, I'm going to talk about propane. I'm going to talk about 4. I'm going to talk about butane. 5. I'm going to talk about pentane. 6 member is known as ethane. 7, I'm going to talk about heptane. 8, I'm going to talk about octane. 9, I'm going to talk about nonane. 10, I'm going to talk about decane. So by so doing, these are the parent name of each of these organic compounds. So when we're going to talk about alkane, for instance, this ANA is changed to ENE automatically. So by so doing, here we're going to have ENE, here we're going to have ENE by changing this ANA to be this compound with these two double bonds. So by so doing, we said the alkane family is given by a molecular formula known as CnH2n plus 2. We say let N take the first member, let it be 1. First member is methane. Let N take the position of the first member. We say whenever we say N, I'm going to introduce 1. We are going to have C1 H21 times 1 plus 2. So by so then I'm going to say C. I'm going to 2 times 1 plus 2. I'm going to have 4. So the first member here, the molecular formula is given as CH4. So I explain the terms homologous series. We say homologous series is a series of organic compounds that follows a structural pattern that each successive member, they differ from each other by what? A CH2 group. So by so doing, if I should add this CH2 group, I'm going to have this next member. Carbon plus carbon, I'm going to have 2 carbon. 4 hydrogen is here, 2 hydrogen is here, I'm going to have 6 hydrogen. So if I should add this, I'll have C3H8. I should add CH2 as well. I'm going to have C4H10. So by so doing, let's use, for instance, now let's use this molecular formula to arrange, to get each of these members using, let's get the molecular formula of this compound using the molecular formula. We'll say CnH2n plus 2. Let's use this third member. We say let n is equals to 3. I'm going to say C3 H2 times 3 plus what? Plus 2. You're going to have C3. 3 times this is 6 plus 2. You're going to have H8. So we are able to obtain this molecular formula for propane using this molecular formula, and we can also add each of these homologous series to have these successful members. So by this, now I'm going to discuss more about the first member for time's sake. So we're going to talk about the preparation of methane. I'm going to talk about the simple reaction this family can undergo, and so on and so forth. So let's talk about methane. Methane. So the methane can be obtained by reacting sodium ethernate. So by so doing, reacting with a soda lime, this soda lime, we are going to have sodium hydroxide from the soda lime. So we're going to have a CH3CO, sodium ethernate, reacting with what? Sodium hydroxide. So we say from there is from soda lime. From soda lime. So if this now, it gives sodium to CO3 plus CH4. So by so doing, this is a simple laboratory preparation of this important methane. So methane is also obtained from a mining site. So in some cases, this is the gas that actually causes a common explosive within mining site, because it's very explosive. It's one of our constituents in our domestic gas here. So in this now, in some cases, they are also known as match gas. A common term also known as match gas. So what are the common chemical reactions that is open to this group of family? What are the basic? So they undergo two important chemical reactions. One of them is known as combustion reaction. Combustion reaction. So the other one, they undergo what is known as substitution. Because they are saturated, this hydrogen can be replaced automatically with any halogen. So by so doing now, if we should have a combustion reaction, we said all hydrocarbons, when they burn in air, they give in excess air, they give a very good two major products known as CO2 plus water. But in this case, if for instance, now let's use methane for a very good example. Let's talk about combustion reaction. When an organic compound burns in air in excess air, it gives two stable compounds. We're going to have oxygen. Let's say this is gas, to give us CO2 plus water. CO2 plus water. By so doing, if we should have this now, first of all, for us to balance this equation, though I'm going to give a separate video on how to balance composition reaction involving hydrocarbons. So in this now, we must balance this carbon first in each. So at the reactant side, we have one carbon. We have one carbon here. We said carbon is 1. Carbon is 1 here. We said hydrogen is 4. Hydrogen is 2 here. So one of the steps, since the carbon is balanced, we must balance the hydrogen before balancing this oxygen that is separate. So the hydrogen is 4. For us to balance this hydrogen, you're going to let's add 2 here. 2 times 2 here, you're going to have 4. We said oxygen here is equals to 2. Oxygen here, you're going to 2 here plus 2 here. Oxygen is 4. So by so doing, for us to have oxygen to be 2 here, 4 here, I can add 2 here, 2 times 2 to give us 4. So this is a very common reaction with organic compounds. They undergo combustion reaction. So whenever you see it in multiple choice questions in JAMB or WAEC, when organic compound undergoes combustion reaction in excess oxygen, they give 2 stable compounds. But when it is not in excess, they give a less compound that is compared to this, a less stable compound that is compared to this. So the next reaction that is open to this compound, they undergo what is known as substitution reaction. In the presence of ultraviolet ray, chlorine reacts with methane to have different important derivatives. So let's use methane for example. Let's use methane reacting with chlorine. It gives different, one of these hydrogen is being replaced, so chlorine will be attached to it to have HCl. So when this H3 C3 react with chlorine as well, we're going to have a C2H2 plus HCl as well. When this compound reacts with chlorine as well, it's a simultaneous reaction. It gives CH3. So when this react as well, C3 is Cl3. Let's have Cl3. This CH, so you are going to have what is known as the hydrogen is replaced automatically by this halogen member. So by so doing, this is tetrachloromethane, this is trichloromethane, this is dichloromethane. These are important chemicals in our industry. So having known this now, we have talked more about this alkane family. So they undergo two important reaction, combustion reaction that involve oxygen, and we'll talk about substitution reaction that this hydrogen, because they are saturated, each of these hydrogen can be replaced by a more reactive electronegative element in the periodic table. A very good example is the halogen family. So this reaction undergo in the presence of ultraviolet ray, that is sunlight. So having known this now, we can talk about the second family known as alkane. Alkane family. Alkane family, alkane. Okay, let's wipe this. Let's wipe this totally, so that we'll have enough space. Talk about alkane. Alkane family. As I've said before now, we said the alkane family is just a representative of the parent name as well. We say this family is changed. Instead of adding ANA, it is changed to ENA, and it has a functional group. It has a double bond as a functional group, and it is given by a formula C8 CN H2N plus what? H2N, just H2N. So by so doing, yeah, we're going to have the first member to 10. So if we should say the first member is 1, first member is 1, we said let n equals to 1. So we have C 1 H 2 times 1. Yeah, we're going to have C 2 times 1 is 2. We're going to have C 2. If you should see this group, we already said in our common terms that this compound, this group is known as homologous series. Homologous series. So this is the reason we don't have methane. We don't have methane as a member under this alkene family, because this molecular formula have been taken over by what is known as homologous series. So this second member is the most important. We're going to talk about the second member. Since we don't have methane, I'm going to wipe it. Let's have N. Let N equals to 2. Now we're going to have C2 H2 times 2. We're going to have C2 H4. So ethane is the next member that we have that is existing. We have C2 H4. So when we add the homologous series as well, we're going to have propene. So as we did in our alkane family, we're going to have C3 H6. So as we add the homologous series, each of these members is successfully replaced by a CH2. So by so doing, we said like this, the last, the 10 member, which is known as decane, we're talking about alkane, it's known as what? Decane. So we're going to add the homologous series to arrive at this compound. So this compound, I'm going to talk about a different reaction because it has 2 double bonds, so they can undergo certain reaction as compared to the alkane family. And ethane is an important gas. It's an important gas. It's an important gas. So how can we prepare this alkane in the laboratory? So a very good example is the dehydration of ethanol. Dehydration of ethanol. Dehydration of ethanol in the presence when it is boiled with concentrated H2SO4. Since it's dehydration reaction, water is removed in this process. When water is removed in this process, you're going to have C2H4. So one of these hydrogen is going to attach to this to form what? To form the water that is removed in this process. So this is a common laboratory reaction that involves alkene to prepare ethene in the laboratory. So in your WAEC, in your JAMB, as I've said before now, the organic chemistry is not all about naming of organic compound using WAEC method. But for you to know the basic reaction, each family can undergo their laboratory preparations and so on is very, very important for your success in your JAMB. So in this aspect now, so since we said the hydration of ethanol can give us ethane, it's a very common laboratory preparation. So in this aspect, let's talk about the common reaction that this ethene is open. So we're going to talk about this ethene. So since it has double bond, they undergo this ethene, this alkene family, they also undergo combustion reaction. So as I've said before, combustion reaction is open to all hydrocarbons. We said too, they undergo addition reaction. This addition reaction is the most important. So they also undergo what is known as polymerization. So in this aspect, they undergo when two or more simple compounds come together. They form a very gigantic structure known as polyethylene. So a very good, like ethene can form in what is known as polyethylene that we use in our industry daily. So like this now, the combustion reaction, we can able that when they react with excess oxygen, they give what is known as, they have a stable compound, carbon dioxide and water is formed at the end. So let's talk more about this addition reaction. So addition reaction of this family, the double bond family, addition reaction. So one of them, it undergo what is known as hydrogenation. So hydrogenation reaction is when an oxygen is added to a given compound. Hydrogenation reaction. So in presence of a catalyst, we can use nickel, we can use platinum. For instance, we say when ethane, we will have hydrogen is added, it can form this bond is used to form this hydrogen. So one of the bond is used for this formation. So addition of this is it's going to give C2H6. So what is formed at the end is ethene. Ethene is formed at this end because hydrogen has been added to this compound to form a C2H6. So we say hydrogenation is a reaction in which hydrogen is added using a catalyst in the process. So we also said the addition reaction, ethene, which is the alkene family, also undergo. It's also react with hydrogen tetra also sulfate 6. So this is an important reaction. Because this reaction leads to the formation of ethanol. So the product that is forming this reaction, when it is boiled with water, it gives what is known as ethanol. So what is now, if we should say C2 reacting with H2SO4. For this now, this double bond will be broken. We're going to have hydrogen here. We're going to have hydrogen here, hydrogen. Going to have SO2H. So by so doing, you're going to have, let's have this. If we should have this, let's have this hydrogen. One of these hydrogen is given. Okay, it's attached. Okay, one of the hydrogen is given out. All right. So if this compound is heated, so we have CO4. We're going to have 4 hydrogen here. Yeah. 1, 2, 3, yeah, 4. So when this compound is boiled in water, so we're going to have ethanol. We'll have ethanol in the process. We're going to have H2H5OH. So this acid is regenerated as well. It's regenerated in this process. H2SO is regenerated. So what we have here is a very good industrial method of preparing ethanol. So we can react ethane with H2SO4 or mix it with H2SO4. It gives what is known as ethyl hydrogen tetrasulfate 6. So when the ethyl hydrogen tetrasulfate 6 is boiled in water, it gives ethanol, and this acid is regenerated in the process as well. So we have so many reactions that involves this ethane family, which is an alkene family. We said they undergo reaction, addition reaction. They can also react with potassium, tetraoxomanganate. So I'm doing this so that when you see a given equation in your JAMB exam or WAEC, it's for you to know the common reaction this group of families are open to. We said in this now we're going to have C2 plus this one is obtained from the tetraoxomanganate. This is oxomanganate. So what is formed at the end? I'm going to have CH2OH, CH2OH. This is known as, if we should arrange this now, we have two carbon, hydrogen here, OH, hydrogen, OH. We say this is ethane. 1, 2 diol. So this is a very important organic compound as well used in our industry. So when you react with tetraoxomanganate, it will give it ethane 1, 2 diol. It's a very important compound that is very, very, very common in our industry. So it can also react with oxygen. We have numerous equations. So due to time, we are going to move to the next family so that we can complete these families in a single video. Let's talk about the alkane. The alkane. The alkane family, they are made up of 3 double bonds. They are made up of 3 bonds. They are made up of triple bonds. So in this now, it is given by a formula CnH2n minus 2. So by so doing, we say each of these member is replaced by from the parent name as the alkane. The AN is replaced by AKN. So each of these, for instance, now the 10 as well, we are going to replace it by ethyne by using YNE. So it's a very simple analogy. So each of the members remain the same, but we are going to change this YANE to YNE. So we are going to have the propyl. You have something like this instead of having propane. So we are going to change the YNE and so on and so forth. So this, what is common to this organic family is that they have double bond. They are given by that formula, and they also undergo simple reaction like the alkane. So they undergo a very simple reaction. So by so then, the major way we can prepare this alkane family is by reacting calcium carbide with what? With cold water. For instance, if we should have sodium, let's say carbon reacting with cold water. Let's have 2 here. You're going to have a calcium OH to have a C2H2. So this is the compound of ethyl, very important ethyl. So we should have, let's have the members. We should have the molecular formula CN H2N minus 2. Let N be 2. N equals to 2. You're going to have CN C2 2 times 2 minus 2. We say 4 here. C2 4 is here minus 2. You're going to have C2. So this is the member, the simplest member of this family, C2HN. They also undergo a very simple reaction as well, like the double bond family. They undergo substitution, combustion reaction. They also undergo addition reaction as well. So by so doing, let's have a very, when they also undergo what is known as hydrogenation as well. Hydrogenation. So in this step now, the hydrogen that will be used in this kind of reaction is twice as compared to the alkane family hydrogenation reaction. So for instance, now let's use a very good one, carbon triple bond. We have hydrogen here. Let's say, let me bring out this hydrogen. So when it is hydrogenated, so we're going to have one of the bond. We're going to have ethene first in this first instance. When it is hydrogenated as well with a molecule of this hydrogen, you're going to have ethane. So it's a two-step reaction. It's a two-step reaction. So the also reaction that is very important today is they also react with a potassium manganate. It also react with potassium manganate. This is all addition reaction. They are all addition reaction. So when you react with potassium manganate, let's have triple bond hydrogen. I have a permanganate. Let's use 4. I'm going to have 4 mode. For us to have this, I'm going to have this. I'm going to have this HO, yeah, the bonded to oxygen. Yeah, it's bonded to oxygen. So it will give ethanoic acid as well. So this is a very important reaction this alkane family can undergo. So they have various uses. In our next topic, we are going to talk more about how to name these organic compounds using this common knowledge of this organic chemistry. Please, in our next topic, make sure you have covered the terms in organic chemistry. We are able to cover this topic, classification of organic compounds, so that if you are naming, so that you have no issue naming each of these compounds. Thank you. Please share this video